हेलो व्यूअर, हम आपको अपने चैनल एजुकेशन एंड इंटरटेनमेंट में खुश आमदीद कहते हैं। आज का जो हमारा टॉपिक है वो है जेल इलेक्ट्रोफोरेसिस के हम डीएनए को और पीसीआर प्रोडक्ट को कैसे एनालाइज करेंगे जेल इलेक्ट्रोफोरेसिस के थ्रू। And Agarose gel electrophoresis is a commonly used for nucleic acid and protein analysis tool. For the preparation and study of DNA, Agarose gel electrophoresis is routinely used. Gel electrophoresis is a procedure in which the molecules by means of gel under the influence of electric field based on their rate of movement. In other words, we can say that the presence and size of PCR products was calculated using Agarose gel electrophoresis. So, why we use the gel electrophoresis is a common question, and scientists why it is used gel electrophoresis for the determination of the band's presence or absence of anything of specific species, genotypes, or the specific band in a specific person. So here you have your chance to try it yourself. So sort and measure DNA strand by running your gel on electrophoresis experiment. In the figure you can you see that a vial that have the DNA, and we can further process it for the gel electrophoresis, and how we use how to prepare this sample, and how to prepare the Agarose gel, and casting unit, and the other things. So in the coming video we can learn about the detailed information regarding that. So polymerized Agarose is a porous material that allows the movement of DNA from negative to positive terminal. You can also know that the DNA is negatively charged, and when placed in the electric field, so DNA will migrate towards the positive pole, we call it anode. तो आप लोग देख रहे होंगे कि ये इलेक्ट्रिक पावर सप्लाई है, और ये ब्लैक टर्मिनल और ये रेड टर्मिनल है। सो ब्लैक टर्मिनल जो है वो नेगेटिव पोल को मेंशन करता है, और डीएनए की मूवमेंट फ्रॉम नेगेटिव टू पॉजिटिव टर्मिनल मूव करती है, क्योंकि डीएनए पर नेगेटिव चार्ज होता है। तो ये आपको जो मीडियम नज़र आ रहा है ये बेसिकली एक पिक्चर के थ्रू आपको दिखाया गया है कि हम एग्रोज कैसे यूज़ करेंगे और इसको कास्टिंग यूनिट में कैसे रखेंगे और डीएनए की मूवमेंट कैसे होगी। ये एगरोज का बेसिकली मॉलिक्यूलर स्ट्रक्चर है, जो कि डी ग्लैक्टोज और 3,6 एनहाइड एल ग्लैक्टोज से बनता है। एगरोज is a linear polymer extracted from the seaweed. So in the ancient times, sweetened agarose gel have been eaten in the Far East since the 17th century. So agarose was first used in biology with Robert Koch, so as a cultural medium for tuberculosis bacteria in 1882. So how we can prepare an agarose gel? Agarose gel के लिए हमें एग्रोस चाहिए और एक स्पेसिफिक बफर चाहिए जिसमें हम एग्रोस को डिज़ोल्व करेंगे। तो बेसिकली दो टाइप्स के बफर हम यूज़ करते हैं, एक को हम TDE बफर कहते हैं और अब एक को हम TAE बफर कहते हैं। तो एग्रोस जेल इज प्रिपेयर्ड बाय कंबाइनिंग एग्रोस पाउडर एंड ए बफर सॉल्यूशन। So while Running the gel electrophoresis, you can be sure that the buffer that you can use to dissolve the agarose is the same. It will be worked in the casting unit. Otherwise, we have the problem or restrictions, and it will affect the quality of the agarose gel at the final end. When we analyze the gel results, I mean, it's not clear, the band is not clear, it will give the faint band, so we can be sure about that. So मैं डिटेल डिस्कस करूँगा कि कौन कौन से इंस्ट्रूमेंट ऑपरेटर्स यूज होंगे। ये बेसिकली इलेक्ट्रिक वोल्टेज है, इसे हम जेल टैंक यूज कहते हैं, और ये पावर सप्लाई है। ये इलेक्ट्रिकल लीड्स हैं और ये कवर है, ये कास्टिंग ट्रे है, ये जेल कॉम्स है। ड्यूरिंग while using the electrophoresis apparatus, it will be consist of the power supply, gel tank, casting tray, gel comb, and electric lead, and a cover that covers the gel tank while operating. Because it will, if it will be open, so we have the electric charge. So the person who is using might be at risk of the electricity during the working operation position. So it should be covered with the cover to avoid this problem. The next you can see the gel casting tray and combs. So while preparing the agarose gel, so we can prepare the casting tray and put the comb inside, and how many numbers that we need, it depends upon if we have the 10, 12, 20 or more DNA, so we can prepare the casting tray according to that, because some instruments are specific, the smaller and bigger, it depends upon the size of the growth and casting gel trays and combs available in the market. So while preparing the casting tray, seal the edges of the casting tray and put the comb inside. Place the casting tray on the level surface. None of the gel combs should be touching the surface of the casting tray. And when you pour the gel inside the casting tray, so be careful that each comb is specifically dipped at a specific place, and 1 centimeter deep. So when it will be finished, so it will be give a position to upload the sample. In this picture you can see the agarose and the buffer solution, and we dissolved it and give 3 to 4 minutes in the oven to dissolve the solution properly, and use a flask that is several times larger than the volume of the buffer, because in the oven it will be boiled and it will be moved outside if it is small. Melting the agarose. So agarose is insoluble at room temperature. You can see from the picture at the right, and agarose solution is boiled under clear solution in the left. So because it will be properly dissolved in this picture, you can clearly see that. So we can use properly and heat properly for properly using in the casting tray. So gently swirl the solution periodically when heating to allow all the grains of agarose to dissolve. Be careful when boiling. The agarose solution may become superheated and may boil violently and heat it too long in the microwave oven. So let cool the gel in the flask at a temperature about 60 degrees. At this stage you can add the staining material. If you are using the ethylene bromide, so you will not use the staining material at this stage, but if you have other than ethylene bromide staining material like acridine, orange, and the others, I will discuss later on at the end of this video. So you can add 3 to 4 micro in 100 ml of agarose gel for proper staining and visibility of the bands while analysis. So the second important thing, When you pour the gel into the casting tray, avoid air bubbles that it will not be present in the gel, otherwise the bubbles while electricity pass out from the system, so it will affect and transfer medium, it will affect the quantity and quality of the DNA or a specific band of the PCR product. When cooled, the Agarose polymerized, forming a flexible gel. It should be appear lighter in color when completely cooled 30 to 45 minutes. Carefully remove the foam and tape and put the gel into the electrophoresis chamber for loading the sample. So, and enough electrophoresis buffer to cover the gel to a depth of at least 1 millimeter. It should be dipped the gel inside the buffer while running. So, the prop when you give the electricity to the operator, so the current really passed from one terminal to the second terminal. Make sure each well is filled with the buffer. After that, if you have the DNA while loading the samples, you know the sample is lighter in weight for the DNA, so we can treat it with the loading buffer. Loading buffer it's composed of bromophenol blue and glycerol. Bromophenol blue gives the color, especially the blue color, and glycerol gives the weight of the DNA, so it will be properly loaded and down in the gel. Sometime if you are not using the loading buffer, so you will not see the DNA either it's go in the well or not. So while using to loading the DNA sample, it should be treated dissolved with the loading buffer dye, you can say it. Okay, and after that, when you properly prepare the sample of your DNA and the PCR product, so you can carefully place the pipette tip over well and gently expel the sample. The most important thing you can see the angle of the tip and of the well. It should be 45 angle, so it will be easily move into the well. If you are using from upward side, from this side, so might be the chance some sample is move out and transfer to in this well. It will contaminate the sample and affect the quality of the gel. Also be careful not to puncture the gel with the pipette. So here in this picture you can see the electrophoresis chamber connecting with the electric leads. So connect the electric lead to the power supply. Be sure the leads are attached correctly. DNA migrates toward the node from the black to red side. When the power is turned on, bubbles should form on the electrodes in the electrophoresis chamber. So it means that the chamber is working properly and the tank receive the electricity properly. So when this condition is happen, so you can say that the DNA will move from positive to negative side. So this is the gel picture after running 30 minutes. So you see that it is the cathode minus sign and here is the anode positive sign. So here is the DNA that move from this position to this position, and you also see this is the well and this is the bromophenol blue that we are using the loading time. So behind it will be the DNA sample, and upside is the bromophenol blue. You can clearly see in this picture. And when the current is applied, make sure the gel is running in the correct directions. You will put the black terminal on the black and red terminal on the red. It will be clearly mark on the tray. So you can see if you're using vice versa, so you have a problem. The sample will move from negative to positive sides. It will be out by this way. So bromophenol blue will run in the same direction as the DNA. So finally you can see the DNA. मैं यहाँ पे आपको बताता चलूँ कि जब हम जेल को रन करते हैं और सैंपल यूज़ किया जाता है, डीएनए सैंपल या पीसीआर प्रोडक्ट को लोड करते हैं, सो पहला द फर्स्ट वन एंड द लास्ट वन, both sides you can use for the ladder, because ladder we have the known sequence, specifically if we are using the 100 base pair, 50 base pair ladder or 1 kb base pair ladder, so the size of each band we don't know that about, because you can see here this is the first one is 100, the second one is 200, the third one is 300, and the last one is 12,000 base pair. So when we compare our samples, either is PCR product or the DNA product here, so we can match the size with the ladder. At the end we can say that our size is 300 base pair for DNA or for PCR product. So in most cases DNA have the higher size, so it will be appear in this range, and for the PCR product it will be appear into 400 and 500 base pair range. So it depends upon the primer that you select specifically for your organism or species that you are using to identify. So inclusion of a DNA ladder on the gel makes it easy to determine the size of unknown DNA. So the very last or the faint band, it will be appear of the bromophenol blue migrates at approximately the same rate as a 300 base pair DNA molecule. So this is the ethidium bromide. The ethidium bromide we can use it for gel staining. So many other staining material also used, like acridine orange. Sometimes ethidium bromide is a powerful mutagen and is moderately toxic. So essential precautions should be adopted when we are using the ethidium bromide during the gel electrophoresis staining and during the working in the lab. So gloves and the overall that you are wearing, it should be compulsory and for all the time when you are working in the lab. So many other staining material can also be used with replace to ethidium bromide, because it's a powerful mutagenic that making the problem carcinogenic also. They have the cancerous effects on the body, so especially on the brain. So acridine orange is a safe place that we can use with replace to ethidium bromide. Methylene blue is also good. Biored and Watts method. Also every staining material have advantage and disadvantage. Light is inexpensive, less toxic, no UV light required, no hazard based disposable. So less disadvantage, less sensitive, more DNA needed on the gel, longer staining, de-staining time. So it depends upon the other replaceable staining material that you are using. So try to find another source rather than ethidium bromide. But if you don't have any other source, so you can use the ethidium bromide, but precautionary measures should be adopted while using the ethidium bromide. So this is the final ethidium bromide required ultraviolet light source to visualize to the gel, the bands on the gel, it will be appear on this one. So this is the high performance ultraviolet illuminator instrument that we can use. Many other instruments from other company also available, but it depends upon your budget and the other things that you have in the lab or in the any other place that you need. थैंक यू वेरी मच. हमारे चैनल को सब्सक्राइब करें ताकि आप तक हर किस्म की जो वीडियो है वो बरवकत आप तक पहुंचती रहे. थैंक यू. तो व्यूअर्स, मैं यहाँ पे आपको बताता चलूँ कि जब हम जेल को रन करते हैं और सैंपल यूज़ किया जाता है, डीएनए सैंपल या पीसीआर प्रोडक्ट को लोड करते हैं, सो So the first one and the last one, both sides you can use for the ladder, because ladder we have the known sequence. Specifically, if we are using the 100 base pair, 50 base pair ladder, or 1 kb base pair ladder, so the size of each band we don't know that about, because you can see here, this is the first one is 100, the second one is 200, the third one is 300, and the last one is 12,000 base pair. So when we compare our samples, either is PCR product or the DNA product here, so we can match the size with the ladder. At the end we can say that our size is 300 base pair for DNA or for PCR product. So in most cases DNA have the higher size, so it will be appear in this range, and for the PCR product it will be appear into 400 and 500 base pair range. So it depends upon the primer that you select specifically for your organism or species that you are using to identify. So inclusion of a DNA ladder on the gel makes it easy to determine the size of unknown DNA. So the very last or the faint band, it will be appear of the bromophenol blue migrates at approximately the same rate as a 300 base pair DNA molecule. So this is the ethidium bromide. The ethidium bromide, we can use it for gel staining. So many other staining material also used, like acridine orange. Sometimes ethidium bromide is a powerful mutagen and is moderately toxic. So essential precautions should be adopted when we are using the ethidium bromide during the gel electrophoresis staining and during the working in the lab. So gloves and the overall that you are wearing, it should be compulsory, and for all the time when you are working in the lab. So many other staining material can also be used with replaced to ethidium bromide, because it's a powerful mutagenic that making the problem carcinogenic also. They have the cancerous effects on the body, so especially on the brain. So acridine orange is a safe place that we can use with replaced to ethidium bromide. Methylene blue is also good, biored and Watts method. Also every staining material have advantage and disadvantage. Light is inexpensive, less toxic, no UV light required, no hazard based disposable. So disadvantage, less sensitive, more DNA needed on the gel, longer staining, de-staining time. So it depends upon the other replaceable staining material that you are using. So try to find another source rather than ethidium bromide. But if you don't have any other source, so you can use the ethidium bromide, but precautionary measures should be adopted while using ethidium bromide. So this is the final ethidium bromide by the ultraviolet light source to visualize to the gel, the bands on the gel, it will be appear on this one. So this is the high performance ultraviolet illuminator instrument that you can use. Many other instruments from other company also available, but it depends upon your budget and the other things that you have in the lab or in the any other place that you need. हमारे चैनल को सब्सक्राइब करें ताकि आप तक हर किस्म की जो वीडियो है वो बर वक्त आप तक पहुंचती रहे. थैंक यू.